Good afternoon and welcome to a very special episode of The Angry Astronaut. I am joined today by Dr. Stefan Brieschenk from Rocket Factory Augsburg. And for those of you who may have watched one of my previous videos about this topic, this is an emerging private launch provider in Germany that is coming out with some very interesting products. And Dr. Brieschenk is the COO of this organization, and I'm sure has lots of excellent information for us today. Thank you so much for joining us today, sir.
Hey, Jordan, thanks for inviting me and really excited to be here.
So we'll get right into it. A lot of my viewers are familiar to some degree with your organization. What a lot of them want to know is about the technology involved. The rocket, your payload is very impressive, at least in terms of a SmallSat provider, well over a metric ton to low Earth orbit, nearly half a metric ton, all the way to geosynchronous transfer orbit. Can you tell me something about the rocket, the technology that's involved, and how you're accomplishing this?
Absolutely. Basically, the technology that we develop here is really somewhat disruptively different to what's out there. And I give you three primary examples. The first example is on the propulsion system. The propulsion system is making use of a closed cycle. That means basically improved efficiency and hence more payload for lower cost. And that is really something that you don't find on a lot of small launch vehicles. It's a very unique propulsion technology, staged combustion, running on Kerolox, and it's really the key technology that makes us so competitive. Then on the launch vehicle structural design, you will see that a lot of it is made from stainless steel, very thin stainless steel. The tanks are somewhat balloon tanks, and that really makes up for a launch vehicle design that's really low cost, but at the same time, really performant, right? If you look at the best performing upper stages in history, you realize that there are stainless steel designs that are basically leading in terms of performance. And that's what we have basically done on the first and second stage. And then last, and this is really one of the most important elements, we have a third stage that's a hybrid. It's a third stage and an orbital transfer vehicle. And it's very interesting because the optimization leads to the point where the OTV does some of the DV for orbital injection. So the third stage is the OTV. The OTV is the third stage. About 10% of the DV that is required for orbital injection is done by the OTV itself. And this is a really interesting point because it basically increases the payload quite dramatically, and it results at a really good basically payload to cost ratio that is putting us somewhat in the lead.
So for staged combustion is something that a lot of my viewers are very familiar with when we're talking about the Raptor from SpaceX. The staged combustion making more efficient use of the propellant, although I guess from what you said, you're using Kerolox instead of Methalox. What other sorts of differences does your staged combustion system have to the Raptor?
So the most important difference is obviously the propellant. It's correct that we use Kerolox. The original plan was to use Methalox, but we realized, hey, wait a second, there's actually no rocket out there yet that masters Methalox as a technology. And we basically said, let's start with Kerolox, but let's make sure that we can convert to a Methalox system at some point in the future. Now, on the Kerolox system that we employ, we have an oxygen-rich preburner, and it's not a full-flow staged combustion engine like Raptor. We basically have full flow of oxygen through the preburner, but only a very small amount of kerosene, a few percentage points of the kerosene mass flow to power the turbine and the turbopump, and then the rest of the bulk of the kerosene is injected in the mixing head. So it's a somewhat, I would say, more straightforward technology for Kerolox, but we believe that we can basically continue to use that engine cycle with a minimum in adaptation if we change to a Methalox system.
Now, you also mentioned your orbital transfer vehicle. Some people might call this a space tug. Would you say that that's a good comparison to make a vehicle designed for a variety of secondary missions after the initial launch?
Absolutely. You can refer to it with many different names: orbital transfer vehicle, space tug, third stage, somewhat different. Every one of these names is applicable. The most important difference is that if you look at a traditional launch vehicle, that's a two-stage launch vehicle that also carries an orbital transfer vehicle or a space tug, you would realize that basically the two stages will achieve orbital velocity, and only once you're in orbit, the space tug will basically start operating. But if you do the optimization, and this is what we have found, if you do the optimization and you ask physics, when would you actually introduce the staging? And please now you are free to choose whatever propellant sizing on the different stages that you want. Then the optimizer would answer that you actually don't stage when you're orbital. The space tug basically starts to burn before orbital velocity. This is an optimization that is quite complex, but it basically makes best use of each stage and basically optimizes the overall staging of all three stages. And this is why I have referred to it as somewhat of a hybrid. We need the OTV for a typical mission to achieve our very high payload that we advertise, but we are free to decide how much payload goes on the OTV, and we are free how much more propellant we take with us. So it's a combination of two very important aspects: performance and flexibility. If we fly a mission, for instance, where we have a customer that only needs a payload of, say, 200 kilograms, but a customer that wants to do a lot of in-orbit maneuvers, then we can do exactly that, because we can just trade in payload versus DV on the orbital stage, on the space tug.
Well, another thing that I find to be very interesting about the mission statement and your philosophy overall that you state on your website is the objective of having a negative sum total when we're talking about space debris, that your objective is to have less junk up there than when you launched up there in the first place. Can you describe how your orbital transfer vehicle might be able to accomplish this, deorbit itself along with other pieces of space debris in the process?
Absolutely. So this is our vision, is basically not to just put payload into space, but really clean up all the space debris that's up there. Now, this is technically extremely difficult to do, but what the vision is that we develop this optimized solution to get into space, and we end up with an orbital transfer vehicle that is there in orbit after the mission is over or successfully completed. And now you can imagine that with every launch we do, we have another OTV in orbit, and the OTV technology we develop in-house is using some componentry from our main investor, OHB, and we have basically sat down with our investor and we have said, look, what are the best components we can choose to make this a really big success story? And we have put together an OTV that has quite a long lifetime. So we have a mean life to failure of about 5 years of that OTV. And that allows us to basically have that OTV operating in orbit for an extended period of time. In the best case, in the final version, a couple of years. And you can imagine, if you now basically have that capability, you can easily, after a mission, focus for many years to just identify and target a piece of space debris that's somewhat aligned to the orbit that the OTV is in. And it will basically have quite some time to dock to that piece of space debris and then deorbit together with it. So this is basically the overall picture that we have, right? We want to be cleaning up space with every mission. We deliver the customer where he wants to go. And then the OTV has many years time, and the team has many years to basically find a piece of space debris that's somewhat aligned to the orbit. And our vision is that we capture that and we deorbit not just the OTV, but we deorbit the OTV plus some space junk that we happen to find during that mission. So this is where this overall negative debris sort of calculation comes from.
Well, it's very exciting, and this is something that is a particular focus of my channel, is the whole space debris crisis that we're facing right now. I find it interesting and a little difficult to comprehend, to be honest, that we have organizations, different various European organizations, plus the ESA, plus the UK Space Agency, plus companies like Skyrora, who also have their own space tug designed for deorbiting space junk. We have so many European companies that are focusing on this particular goal. We do not have this sort of reciprocity anywhere else. We don't have, we have interest in the United States, but the vast majority of private space companies really don't focus on that very well. We don't have a whole lot of interest in that, in Russia, China, etc. Why is that, do you think? Do you have any idea? You speak a lot to the space flight community in Europe. Why is it that the Europeans are more focused on that?
Yeah, no, Jordan, your last question on space debris. How do we get to a point where we have so much space debris? Look, it's really frustrating to see what the pollution up there has basically resulted in. It's very accurate to say that space debris or space junk in some sense is in certain orbits more difficult than nuclear waste, because it's going to be there forever. It's really like that. Nuclear waste, at least it goes away also after some very long time spans that no one wants to basically be responsible for right now. But space debris is even worse, because once it's up in orbits that extend a few hundred kilometers, you have no chance to get rid of it other than actively removing it. And it's really a good question that you posed. How does it come that we have all these bodies that are trying to regulate, and yet we generate more and more space junk, or at least have generated so much space junk at this point in time? I can't answer it. I can't answer why we have gotten to that point now, but it's very clear we have to change the direction, and we have to move towards a service that removes space debris instead of creating more of it. It's really that simple. And that's basically what we want to do. It's our focus. We want to develop a service that removes more space debris than it generates.
Well, that's certainly an objective we should all be looking towards, and yet it doesn't seem to be one that's shared by the vast majority of private space companies, sadly. It's unfortunate to hear that. Moving on, so, aside from the things that you've described to me so far, obviously the SmallSat industry is going to become an increasingly crowded and competitive place. How is it that Rocket Factory Augsburg, who obviously is getting into the game substantially later than Rocket Lab, than Virgin Orbit, etc., how are you going to be competitive and get yourselves into that market?
See, the core difficulty is competitiveness, as you said. And there's a few aspects that you need to be really worried about. You need to be really worried about basically developing a service that takes so much non-recurring cost that it's difficult to amortize it again. Arguably, this is what happened to some. Once you have spent a really large amount of money to develop this service, you can't go back. And now you have to create a very competitive product to amortize that investment, because an investment is not free money. Investment means you need to pay that back with some gain on top of it. And this is where we basically come in late. We come in late specifically because we have understood what the competition is doing. We understand what all of these concepts out there are doing, and we strongly believe that coming in late to this party is actually really beneficial because we have seen the big mistakes that were made, and we think for us it's actually the best time to enter because we don't want to make any of these big mistakes. And what that relates to really is we want to spend a very small amount of money. We want the non-recurring development costs to be really small, such that we can basically amortize it and be competitive then thereafter. And it's so difficult to create an access to space solution. I think a lot of people drastically underestimate how difficult it is. At the end of the day, a launch vehicle has less than 3% of a payload mass fraction, and that means if you look at a launch vehicle as it takes off the ground, less than 3% of it ends up as a satellite in orbit. It's incredibly difficult, and there is no such dynamic where you need to be first in the market. It's nothing like a software product where you need to basically be first in the market to capture a lot of attention and gain a lot of customers. But this sort of development is completely different. You need to create something that allows you to offer the very best cost point per kilogram delivered to service. And our aim is to basically be equally or more competitive as the most competitive offers out there right now. The most competitive offers out there right now, they come from SpaceX. If you basically break it down to the per kilogram price, and this is exactly what we're offering. We are offering the same price, but if you launch with us, you have additional flexibility because we can basically launch any customer any day. There is no big rideshare mission. We have rideshare missions, but they are not nearly as large, and we are sort of the taxi, whereas the big rockets out there, they're like buses. You need to be there at a certain point in time, and the bus will go and it will drive exactly into a certain orbit at this point in time, and you can't really dodge either side. You need to be there at that point in time. With us, it's different. You have significantly more flexibility. We are basically the taxi ride that offers you the same cost than if you would choose the bus service.
Are you offering reusability on your booster?
The reusability aspect is not really something that the customer needs to be concerned about. Our first stage is reusable, but the first missions won't be. The first stage will be reusable for the business plan because we want to basically go to a very high cadence, and we don't want to build that many first stages. If you compare the first stage construction and manufacturing effort to the second stage construction and manufacturing effort, you realize there's a huge difference. It's almost an order of magnitude. And we want to recover the first stages to basically enable our business plan and reduce the non-recurring cost that we need to industrialize and build so many vehicles. So we basically, in our vision, we will build a certain amount of first stages that are reusable. And these are basically reused, and the continuous reuse allows us to basically be very smart with every euro of funding that we receive, because there is no need to basically create a huge manufacturing environment because we reuse the first stages.
Now, to add on to that, there are two actual questions. Number one, can you share with me a rough idea of what sort of funding you are receiving, or what the funding that it's going to be required to get you to orbit? And number two, what sort of cadence is your ultimate goal?
So on the funding question, the answer is really straightforward. Since we are, as you described it, we are quite late to the game, which we consider a huge advantage. We don't consider it a disadvantage at all. We know exactly how much other ventures have spent. We know exactly how much money they have used. We know roughly from what's officially documented in the internet available what it was used for. And we can be very smart with allocating that funding that we receive to basically achieve a better overall outcome. In short, we want to spend less money than anyone else, And that is exactly why we're able to basically offer a better price in the end with our service.
And then the cadence, your launch cadence objectives?
Yeah, so we basically, it's very important to consider that we have investors that bring much more to the table than just funding. We have a strategic investor, OHB, that basically launches their own satellites, and we have plenty of satellites to launch. That's a really unique differentiation between us and really most of the other small launch companies. We have satellites there to launch, and we basically planned for a minimum cadence of 10, but we continuously increase the cadence up to about a weekly launch. Now, many companies have promised weekly launch, but the reality is that none of them have achieved it. And if you want to be really honest about it, you would realize a lot of them have used up so much funding that it will be really difficult to offer something like that at a competitive price. Now, we have still the option to hit these milestones because we are late to the party, as you said it, but we have been extremely efficient with every single euro that we have spent. And so far, every decision we've made has turned out to be a really cost and time saver. And it's all going exactly into that direction where we can offer that price point that I outlined before.
Now, another question from one of my viewers, he's German himself, is the experience that he has with German bureaucracy and the challenges, unique challenges that your government sometimes presents. Is this something that has proved to be a unique problem for private launch providers in Germany, or is the German government very cooperative? Or is it in between?
Long story short, no matter where you are on this planet, it's really difficult to launch something into space. It comes with a lot of risks and a lot of responsibilities. I don't think you can make blanket statements to say it's more difficult to launch from one place rather than the other. The entire circumstances are way too difficult to basically isolate such a generic statement. Long story short, we think Germany is a huge advantage for us because first of all, we can basically attract a lot of talent, international talent. We're operating with talent from basically all over the world. It's really unique. If you look at a lot of the American launch vehicle companies, you will find that there are rules that don't allow these companies to hire international talent from the same overall pool that we can do, which is a huge advantage. And we have basically an industrial basis that is unparalleled. Germany has an industrial basis where you basically find almost anything you need for that launch vehicle, at least in the process, already available for you. And this is also something that is so unique and advantageous that I would definitely say that it's a huge advantage to be placed here in Germany over anywhere else on the planet. And long story short, the launch topic is basically not necessarily a German topic. We don't launch from Germany. Our aim is to launch somewhere from the European territory, but we will operate launch sites all over the world. And no matter where you go, you will have to apply to the specific rules that are basically in place where you want to go. Those are different from country to country, but again, this is you can't really have any differentiation here because if you're flexible with the location where you launch to, everyone has to basically go to the same places.
So if we're talking about going to the same places, who's making the short list as far as spaceports are concerned? Are you looking to launch from Norway as Isar Aerospace is looking to launch? Or are you looking to launch from somewhere in Scotland? Who's making the short list right now? Any ideas?
Yeah, absolutely. We've made a really competitive short list, but I will not reveal them to you, Jordan, because we consider this a competitive advantage. We have basically started with the development of the launch tower We actually are already in the procurement phase, and we are constructing it somewhere on our available premises, but we cannot reveal to you where it will actually be located for the first launch at this point in time. But as we said, Norway is one option. We have various options on the table, and there is no shortage of those options. This is really the fantastic situation of our time. There is no problem of finding a place and a licensing body to be doing the actual operations, because it's a global competitive market for launch, and there are more than enough options available.
Well, it's all very interesting, extremely exciting stuff. Is there anything else that you would like to add? Generally, the interviews run about 30 minutes. We're starting to hit that limit now. Any additional details you would like to add for the benefit of the viewing public?
It's basically, I would like to make an appel. If you're a space enthusiast and you're looking for a really cool team to work with, come and apply at Rocket Factory. We have a super international team, more than 30 nationalities. It's basically more international, more open, and more exciting than any sort of venture that I've ever worked in. And it's something truly unique. If you want to join that sort of experience, now is the time to do it. We are hiring, so shoot us an email, go to our website, and maybe I'm able to interview with you at some point in the next couple of weeks.
Well, speaking as an American, this is a fantastic opportunity, I would think, for a lot of people, because companies like SpaceX will not hire people who are not American citizens. We are incredibly guarded about that sort of stuff here. So to hear that, we have companies that are embracing international collaboration within the walls of their own organization, I find that to be very inspiring. So danke sehr für die Auskunft, and I really wish you all the best and all the success in the world with what you're trying to accomplish.
Thanks, Jordan. Thank you very much for the interview. It was really exciting to talk to you, and all the best for you and your channel. And greetings to your viewers. We'll see each other again.
So I think all of you will agree that Rocket Factory Augsburg is yet another example of European innovation and European spaceflight that deserves a lot more media attention than it is getting. So until more channels and more media sources start covering this important development in private spaceflight, I urge all of you to stay angry about space.